Good afternoon, everybody. My name is Saeid Cheraghi. I'm a research associate at Metal Earth, and mainly I'm working on seismic data. Today, I am showing some results from Matheson and Timmins area. So I will show how seismic imaging could contribute to show attributes of fault zones, deformation zones, and also I will show the integration of seismic results with the MAG and MT data. So, and there will be two examples. This is the Abitibi Subprovince geological map. I think you have seen this map a lot with research sites from the metallurgists. And I will show the examples from Timmins and Matheson. And the motivation is that these two areas have similar geological formations, and they are crossing over the same deformations. The first example will be from a high-resolution seismic data in Matheson. Previously, Hogarth et al. Used one section of this data, and along with regional seismic data, MAG, gravity, and MT, they provided a 3D geological model for this area. The geological section in B is from their results, and they show Porcupine Distor Fault in the south and also Pipestone Fault in the north. So I'm showing the results from this high-resolution data. There are two profiles, one east profile and west profile, and seismic shots are only acquired on the east profile because of logistic reasons, and transmit points are distributed between west and east profile, so give us an opportunity to process this data as a 3D data set as well. So the manuscript on this data set are results of collaboration between Metal Earth and Uppsala University, Sweden. So I will show first the west profile, which crosses on the Porcupine Distor Fault. As you see in the shallower part, the seismic image doesn't have good resolution because there is no shot on the west profile, and the distance between east and west profile is about 1.5 kilometers. So, but we can see the reflections under the clastic rocks of Porcupine Distor, and also deeper reflection are interpreted as mafic rocks of Tisdale. And this transparent area is like intrusion, and the deeper reflection is interpreted as Deloro assemblage, and it's iron cap rock. If we look at the east profile, which crosses Porcupine Distor and also Pipestone, we can see better image for the formation. Again, those reflections associated with the Porcupine, clastic rocks of Porcupine, mafic rocks of Teesdale, and also Kid Monroe mafic rocks. Mostly what we see is subhorizontal reflections, and the truncation between clastic rock and the mafic rocks could be Porcupine Distor Fault. And it seems that more complicated structure under Porcupine Distor Fault, this is saucer-shaped reflection, and it suggests the Pipestone is a subvertical formation. And what we see, most of the reflectivity is in shallower cross. I mean, when I say shallower cross, is about 3 kilometers. And this dashed area, we will look at them again in more details. If we look at the cross profiles from east profile and west profile, without using 3D data set, we can see similarity from the reflectivity pattern, and we can extrapolate reflections from one section to the other section. like from clastic rocks and also from the mafic rocks, and also the area for the intrusion. If those dashed area I mentioned in previous slide around the Porcupine Destor Fault and Pipestone Fault, when they are integrated with the MAG data, this gray part is the isosurface from the mafic area. So the isosurface only shows the area dominated with mafic rocks. So around the Porcupine Destor Fault, we can see shallowly dipping fault. It could be interpreted. Hogarth et al. Also had this interpretation. And what we see around the Pipestone, it would suggest the subvertical fault for the Pipestone. And if we look at the 3D data set in the northern part of Matheson area, I considered pre-stack time migration with a cell size of 50 by 50, and it provides more details about the Pipestone fault. We can see north dipping, south dipping reflections next to that saucer shape reflection in 2D. These reflections A and B are not imaged in 2D processing. And we can see truncation of reflection under the fault zone. To better understanding the fault zone, also edge detection and edge detection filter is applied. This dashed ellipse clearly shows the reflections are truncated, and it suggests the subvertical fault for the Pipestone. And if we look at the 2D and 3D processing together, the first row mostly shows integration of 2D sections and also 3D data set, and how we can correlate reflections from one line to other in shallower and deeper part. But the interesting part is when we look at the depth slice from the 3D processing on the Pipestone fault. So about those A and B reflections, which are not imaged in 2D processing, we can see A reflections dipping towards the south and B reflection dipping towards the north. They are interpreted B reflection as in a Gad intrusion, and also A reflection, they are associated to clastic rocks. And also, if we look at the truncation of reflection in A package, it would suggest another fault close to Pipestone fault. So this fault also wasn't imaged with a 2D data set. And the other thing is that the deformation toward the depth is weak. So it's only located in shallow cross at depth less than 3 kilometers. And the last row also shows more geometrical info about the A and B reflections and their integration with east profile 2D. So what we learned from Matheson data is that the faults are kind of shallow. They are located mostly in upper cross, not deeper than 3 kilometers. The next example will be from Timmins data. There are 2 lines here, Crouches Regional and South Porcupine High Resolution. These 2 profiles were acquired for Discover Abitibi, and previously were published by Snyder et al. In Tectonophysics. So recently, metallers acquired MT data around the Crouches area, and this motivated me to process, reprocess seismic sections around this area again. So a special thanks to Dr. Gilles Belefler from GSC, who retrieved the data for us. And in Crouches data, you can see those red lines show the shot line. There is a gap in shot line, again, because of logistic reasons. And I would like to see, is there any similarities between the Timmins area around the Crouches and South Porcupine to Matheson area. First, this is a Crouches regional line. Standard processing is applied to this data. As we see, lots of reflections from near surface down to depth of 12 seconds or about 30 kilometers. So in the south, we can see antiform, it's a kind of regional, about 20 kilometers. And in the north, mostly we can see truss structures. I tried to just delineate most of these truss structures or antiform, and these are alongside the interpretation Snyder et al. Had for this area. The interesting part is that this deformation or reflectivity pattern is not just limited to the upper crust, and is just continuing towards the depth. And many of the reflectivity or truss structures we can connect from the north towards the south. And truncation of reflections, these red dashed lines suggest for the fault. I also integrated with the MT data in this area recently acquired, and we can see conductivity under the antiform, and especially some fingers coming to the surface on the flank of antiform. And this also, again, this conductivity around these deeping reflections in the truss fault, and also this fault zone. So if we look at in a zoom view in the south part and for the antiform, to look at the reflections in more details, we can see this antiform under mafic rocks of Kid Monroe, and also its flank and lots of reflectivity. And if I'm right, even we can see here a truss on the flank, and all these truncation would suggest for fault zone. Toward the north, if we look at toward the north, again, we can see this in more details, steeply dipping reflections, this fault zone here, another fault, and also truss structure, and possible fault zone in this area, in the regional. Again, I would like to emphasize this reflectivity or reflectivity patterns, or these structures are not just limited to the shallower crust. They are continuing towards the deeper crust. Also, the high resolution line from the South Porcupine. First, what we see is a flank of showdown in this area, and also its connection with the mafic rock and possible fault zone. And also under the Porcupine deformation zone and mafic rocks, we can see the truncation of reflection and the fault zone. And the deeper reflections, Snyder et al. Interpreted as intrusion, felsic intrusion. Again, in this area, also the faults are deeper compared to Matheson area. And if I overlay MT data, clearly shows a resistive, conductive under the Porcupine Destor fault zone, which would help for better interpretation. In conclusion, I would like to say, yep, in the Matheson area, we can see the formation zones and fault zone only in upper crust, less than 3 kilometers. But in Timmins area, the formation zones or fault zone are deeper, and they are connected to reflectivity pattern down to depth of about 3 kilometers. And MT and MAG integration with seismic data helped us for better interpretation. And for future work, I would like to work on petrophysical data to better understanding of the reflectivity pattern in this area. And at the end, I would like to acknowledge my colleagues working together, and also special thanks to Professor Julin from Uppsala University. When I was a student, that I learned a lot from Chris. And thanks for your attention. That's it for today. Thank you.
Thank you very much, Saeid. We have time for questions.
Yeah, I have a question, Chris Julien here.
Yeah.
Can you go back to just before the 3D imaging?
This one, Chris?
No, yes, this one, yeah. Are these data migrated?
Yes, this is stag migrated data.
Because it seems rather odd on the left end of these profiles, you have reflections which continue to the very edge of the profile, but they're dipping off the profile. So I'm wondering how is this just part of the profile, or?
Yes. This is only part of profile.
Okay.
Talking about C and D.
Okay, so this is just the profile is much longer than what you show here.
Exactly. Yeah, just around the front. Yeah.
Okay.
Yeah.
And then I was also wondering when you show these faults on some of these sections, these deeper faults, they seem to end quite abruptly. Is there some reason for this? You would maybe expect them to continue to the surface or continue deeper down.
For Matheson area?
Yes, if you just go forward.
Yeah. You know, I didn't extend this. If I show the this model from the Hogarth et al. So this model is based on regional data and also high-res data, MAG, MT, gravity, seismic. So they are suggesting fault zones are not extended toward the depth.
No, but this is not the question. If you can continue.
Okay.
Yeah, continue. Yes, it's on this one. Yes, I mean you have some very short faults here at depth, which end abruptly. You have, I don't know what the blue lines actually mean.
Thrust structures. I just delineate thrust structures.
So these are thrusts.
Yeah.
And these more vertical faults end on the thrusts. Is that right?
Yeah, I just we recently started working on this data. This is my guess. I just put some dashed line for potential fault. It doesn't mean they are necessarily correct.
Okay, so this is just a very preliminary markup of the section. Is that right?
Yeah. This is like the DMO stag migrated section. I just tried to put some starting point for my work, my future.
Yeah, I think you need to consider how this is geologically consistent when you mark this up.
Exactly. Yeah.
Yeah. Okay. Fine. Thank you.
Thank you, Chris.
I have a question, Ross. It's Jeff Harris.
Go ahead, Jeff.
Yeah, I enjoyed your presentation. In the overall goal of Metal Earth is looking at productive versus non-productive belts. Can you assume in your talk that Timmins, because the faults are deeper, are more productive than Matheson, where the faults are more shallow? That's one question I'm wondering, or is that too infantile too?
Thanks, Jeff. Yeah, I need to brave to say such a thing, but somehow I try to say passively. You know, uh, we had a discussion the other day in one of our meetings. We need to provide kind of a checklist based on everything we have, because at the end is not just the target is not just processing seismic data or empty data or whatever data we have. It's integration kind of criteria or checklist to say to people, okay, hey, this area is metal and dove or it's not. And I guess this is ongoing thing. We need to work on that. And thanks, you are mentioning this. So,
Okay.
Yeah, I wasn't brave to completely have this conclusion, but yes, when you are saying, yeah.
Yeah. Okay. Thank you very much.
Yeah.
We have time for one more question. So Saeid, how does your interpretation, Dave Snyder is on the line here. How does he compare to Dave's interpretation of these transects?
It's mostly covers Dave Snyder's interpretation, but in the paper Snyder's et al. Published in Tectonophysics, they mostly considered, I guess, about as I remember correctly, less than 8 kilometers in upper crust. If they can, yeah, in Tectonophysics, but more here we are looking at entire the 12 seconds of data. But yeah, my interpretation is alongside what Dave had in this area, Crouchest and South Timmins and other ones. Yeah.
Okay. All right. Any other questions?
Ross, since you have time, I could make a quick comment to that last question.
Yes, please do, David.
So I'm maybe biased a little bit toward thrust tectonics when I interpret seismic sections. So the old Abitibi, Discover Abitibi interpretation was sort of dominated by thrust stacks and anticlines. And I think it's probably valuable for Saeid and the group working on the Timmins data to step back and approach it sort of with an open mind, like Saeid was presenting today, because I think the MT data that's new is going to provide some insights that I didn't have available when we were writing that original paper. So my general thoughts on the comparing Matheson to Timmins at the moment is that the Timmins area had a lot more horizontal shortening during the D2 deformation than did the Matheson area. And the key question related to gold emplacement perhaps is, when did that shortening occur? Was there some gold concentration and emplacement before the shortening, and then during it and after it? And if we can sort of get that timing right, it would make a big difference, I think, in trying to address some of the final goals, like Jeff Harris asked that question. So I think the MT data is going to show us where the fluids flowed, which would be where there would likely have been some sort of extensional faulting, maybe in the anticlines of the thrust, preferentially. So I think, this is a good place to be with this at the moment. And I think the group that's looking at it is probably going to have some interesting insights that we weren't able to achieve, back in the Discover Abitibi project.
Thanks, David. Yeah.
Thanks, David. Appreciate it.
Sure.
Just checking, Ross. Can you hear me now? It's Matt?
Yeah, I got you now.
Oh, okay, good. I guess it kind of followed what I was going to ask, sort of follows on from what David was just saying. But Saeid, at the one part of your section there, I guess at the north end, there's a structure, looks like, in the seismic that's dipping about 45 degrees, and then right under the Kidd Monroe assemblage there.
Let me show this.
Go back. Go back 2 slides, please.
2 slides here.
There, yeah. So, yeah, right under the Kidd Monroe assemblage there, you've got what looks like a prominent reflector of some sort, and then your MT cuts right across it, and you know, dipping the other way, so to speak. And I'm just wondering if it's too early to try to do any sort of cross-cutting relationships. As I said, it's kind of what Dave was kind of just saying there, but in terms of you know, which came first, I guess, and how that's affected the evolution of the crust and that kind of thing. You see what I mean?
Yeah. You know, as I said, you know, we recently started to work on this data. So about a month ago, I processed this data. I finished the processing. Our AMT data is fresh. There are a couple of people from the geology, from the geophysics working on this data. You know, we're just learning, and my main purpose just to show my preliminary results. So we are working on that. Yes, yeah, of course. In my point of view, I can see better correlation with this antiform and conductive area here. Yeah, but this area, yes, needs explanation. And at the moment I'm talking to you, I don't have that explanation, sir.
Oh, no worries. I didn't think you would. I know it's early days, but I just pointed that out because that's an interesting one where you've got an obvious sort of dichotomy in what you're seeing between the seismic and the MT. So yeah, no, cool. Thanks, Saeid. No, great talk, man.
Thank you.